Hello everyone, Mr. Fawcett here, and we are back for another Algebra 1 lesson. Today we're going to focus on two-step equations. So the last video we did one-step equations, made sure we had those down pat, and now we're going to move on to equations with two steps. We're also going to throw some equations with decimals as well as fractions into today's lesson as well as your practice. So again, make sure we're proficient with all different types of numbers and not just integers. Okay, we are going to do, and maybe you want to write these down, we're going to do numbers 1, 2, 4, 22, and 26 on the video. I would encourage you to work through those before you see the answers and explanations. And then afterwards, you will have the rest of these to work on. Okay, let's get started with number 1. Okay, so we have -1 minus 2x equals -17. And again, our goal is to get the x by itself. So we need to think about what inverse operation should I do first. Now, there's no set order in the ways you have to do inverse operations. Okay, it's not like you have to always add to both sides before you divide from both sides, or you always have to multiply before you subtract. It just may make the problem easier based on which way you pick to do your inverse operations. So there's two things I have to do to this side to get the x by itself. I'm going to have to move the -1 to the other side, and I'm going to have to divide by -2. Now we can think, okay, which one should I do first? And I'm going to show you both, and then we can kind of talk through which we think is easier. So the first way is I'm going to add 1 to both sides. So these simplify. I'm left with -2x is equal to -16. -17 plus 1 is -16. Okay, now I'm going to divide by -2. Remember, you have to divide by the negative as well. So this is going to give me x is equal to +8. Because I'm dividing a negative by a negative, that's going to give me a positive value. So this is the way that I think is the easiest. It's not the only way you can do this problem, though. Let me show you one more way. I'll do this in light green next to it. So if I have -1 minus 2x is equal to -17. Now maybe you think, okay, I want to divide by -2 first. So you divide. Oh, I don't need, we'll get rid of that. So you get -1 plus x is equal to 8.5. Okay, now, did we perform this division correctly? So did I divide by -2 on both sides? Well, here's the problem. I divided the right side by -2 because there was only the -17. So I divided -17 by -2. That's fine. The problem is on the right side, I didn't divide the entire side by -2. If I was going to divide the entire side, which is what I have to do, well, I would also have to divide this -1 by -2, which in this case would give me +1/2 down here. So now we're okay. Now this equation is correct. And then if I wanted to move the 1/2 to the other side, I would have to subtract 1/2 from both sides. That would give me x is equal to, now I've got to add a decimal with a fraction, so I could convert one to the other. So I get 8.5 minus 0.5, and I get x is equal to 8. So we got the same answer even though we did our inverse operations in the opposite order as the purple, right? So the purple over here, I added 1 to both sides first, and then I divided by -2. In my green example, I divided by -2 first, and then I moved the 1/2 to the other side. It's up to you, but generally doing it the way we did it in the purple is going to be a lot easier, right? And you can tell that we seem to have fewer steps, and we didn't run into any extra fractions and decimals. So I don't want to give you the specific way that I think you should do these problems. I kind of want you to explore on your own, right? And it'll be up to you to figure out what is easiest mathematically. It's good to know how to do it both ways. I would prefer that you know how to do it both the purple way and the green way, but also understand that the purple way is more efficient. So the more you experiment, the more you explore with different types of ways to solve these problems, the better you'll get at understanding which inverse operations you should do first. Okay, on to number 2. I'm going to clear what I have for number 1. And I'm going to scroll up a little bit. So again, this problem can be solved in a number of different ways. And I actually think that your immediate thought may be, okay, I've got a set of parentheses on the left as well as this 4, so I'm going to distribute. Perfectly fine. So it's going to give me -4 plus 4n is equal to -4. Then I could add 4 to both sides, and I'd get 4n is equal to 0. Divide by 4 to both sides, and I get n is equal to 0 divided by 4 is just 0. So I get n is equal to 0. Perfectly acceptable method. You'll notice, though, that this actually took us 3 steps, right? 1 to distribute, 1 to add the 4 to both sides, and 1 to divide both sides by 4. However, I said this lesson was a lesson on 2-step equations. So there must be a way to do this in 2 steps rather than 3. It doesn't mean this way is perfectly correct. It'll get you the right answer. But let's think about if there's a way to shorten it. Okay, is there a way to get rid of one of these steps? Could I do something first other than distribute the 4? And the answer is we can. Let me rewrite this problem real quick. We'll use light blue, I think. Trying to think of a color that goes well if I have to go on to the gray. I guess we'll just use green again. So I'm going to rewrite the problem. So if we look at this side of the problem, we actually have multiplication going on here. We have the 4 times what's inside parentheses. So I could actually use division to simplify the 4. So let's see what happens if I just divide both sides by 4. Well, these 4 simplify. I'm left with -1 plus n is equal to -1. -4 divided by 4 would be -1. So that was one step, and you can pretty clearly see that the second step should be adding 1 to both sides. That leaves me with n is equal to 0. So again, 2 ways of doing the same problem, both correct. One was 3 steps, one was 2 steps. Good to know how to do it both ways. Right? Sometimes it'll be more beneficial for you to just divide right away. Sometimes it'll be more beneficial for you to do your distributing. Different problems can pose you different types of scenarios, and you want to be able to manipulate the equation in more ways than just one. Okay, we are going down to number 4. We see a fraction here. Okay, so again, problem can be approached in multiple ways. The first way that I'm going to do it again, for 2 steps, is I am going to subtract 1 from both sides. Okay, that's going to simplify this part of the left-hand side. So I'm going to get a divided by 3 is equal to negative 2. Negative 1 minus 1 is going to be equal to negative 2. Now, how do I get rid of that 3 in my denominator? How do I simplify that out? Well, I've got to do the inverse of dividing by 3, and that's going to be multiplying by 3. Got to multiply both sides by 3. So that is going to give me a is equal to negative 6. So 2 steps for this problem as well. Now, could we have multiplied by 3 first rather than subtracted negative 1? Well, let's see. Let's see what we get if we do that. So if I have a divided by 3 plus 1 is equal to negative 1. Let's see what happens if I multiply by 3. Oops, that's not a very good color for over here. So these may simplify. I'll get a plus 1 is equal to negative 3. Now, think about it. Did I do this multiplication correctly? Did I multiply 3 to both sides? Take a minute, pause the video, think about whether I did that correctly or not. Well, the answer is I didn't, right? And I'm purposely throwing some mistakes in here just so we can talk about the common errors that students sometimes make. This is the danger of doing the problem this way. Okay, if we multiply 3 to both sides, I have to do it to every part of both sides. So let's go back up here. The right side is fine, right? I multiplied the entire right side by 3. The problem is on the left-hand side, I have to multiply, I have to multiply both terms by 3. So this 3 gets distributed to both terms. For the first term, we just get a. For the second term, we get 3 though, because 3 times 1 is 3. So you have to distribute that 3 not only to the a over 3, but to the 1 as well. Then if I subtract 3 from both sides, I'm going to get a is equal to negative 6. And we get the same thing as we did with the red and blue equation. So again, you could multiply 3 to both sides first, or you could subtract 1. Both are going to get you the same answer. You just have to make sure you perform the inverse operations correctly. All right, onward we go. We're going to jump all the way down to 22. I believe we're going to look at one that has a decimal in it. All right, so for 22, the only thing that's different about this problem is that we're working with decimals rather than integers. But inverse operations are still going to act the same way. So let's look at this equation. Let's think about the first thing I should do. I have this 4.5 in my denominator. And to undo that, right, to simplify out that 4.5, I need to multiply both sides by 4.5. So on the right-hand side, that's easy because they just simplify, and I'm left with k minus 6.6. On the left-hand side, you may have to pull out your calculator here. That is going to give you 10.8. So 4.5 times 2.4 is equal to 10.8. We do have a negative here, though, so it's going to be negative 10.8. Okay, and then I'm just going to add 6.6 to both sides. So that is going to give me k on the right-hand side, and that's going to give me negative 4.6. 0.2 on the left-hand side. So again, same process, just different types of numbers we're working with. Let's see if we could do this problem in a different way and still get the same answer. Okay, so let's think about adding 6.6 to both sides first. So add 6.6 to both sides. And let's think about if I get the same thing. So on the left-hand side, I would get positive 4.2. And on the right-hand side, I would get k divided by 4.5. Now, again, I purposely threw in a mistake here. Think about where that is. So think about what mistake I made when I added 6.6 to both sides. Okay, so on the left-hand side, it's no problem, right? I'm just adding 6.6 to negative 2.4. The problem is, on the right-hand side, I can't just add the 6.6 to the negative 6.6 because one is a part of a fraction and one isn't. I think this is going to be more clear if I rewrite this in a different way. So if I do negative 2.4 plus 6.6 equals k minus 6.6 divided by 4.5 plus 6.6. So now I think it's pretty clear that we cannot just add these two terms together, right? We can't just add the 6.6 to the negative 6.6 because one is being divided by 4.5. I would have to find a common denominator here before I could add these two terms together, right? Because the denominator on the 6.6 is 1, the denominator on the other fraction is 4.5, and I can't add two fractions together if they have different denominators. So while the other problems were not too bad when we tried to do them a different way, this problem becomes significantly harder when we want to do it this way. So my suggestion would be, if you're running into something like this that it seems a little harder than it should be, I would just think about, okay, was there an easier thing I could have done first? Right? And then you would think about, okay, maybe I could have multiplied both sides by 4.5 like we did during our first attempt, and that would make it a lot easier. Let's go through the algebra here just to show you that it still is possible to get the same answer here as before. Let me erase this. So if I need to change this denominator here to 4.5, oops, let me get my pen. I need to change this to 4.5. I'm going to multiply this whole fraction by 4.5 over 4.5. So then I'm going to simplify my entire equation. On the left-hand side, I'm going to get positive 4.2. Then I'm going to get k minus 6.6 divided by 4.5 plus 6.6 times 4.5 is 29.7 over 4.5. I can now combine my two numerators. The k is going to stay the same because there's nothing being, we can't add numbers to k, they're not like terms. And then negative 6.6 plus 29.7 gives us positive 23.1. Now we're at the point where we could multiply both sides by 4.5. You can see how much longer this way is taking me, right? 4.5 times 4.2 gives me 18.9. On this side, my numerator, or my 4.5 and my numerator and denominator simplify, and I'm left with k plus 23.1. If I subtract 23.1 from both sides, that is going to leave me with negative 4.2, which is what I got for k the first time I tried it. Let's make sure we know that's a 2 right here. Okay, so it is possible to do it this way, but it is significantly difficult. So again, the best way to do this problem would be to multiply both sides by 4.5 right away. Then it becomes an easy two-step problem. If you don't do that, then you've got quite a few steps with the algebra being significantly harder. Okay, let's quickly look at 26. I know we're already past 20 minutes in this video, but I thought it best to show you the number of different ways you could solve these problems. So 26 also has some fractions in it, but it is not as bad as trying to do the last problem, the second way. If you think back to previous videos, first thing that I would do is I would convert these mixed numbers to improper fractions. So I'm going to get 7/10 is equal to m. To convert this to a improper fraction, you multiply the number, or not the number portion, you multiply the whole number portion, the 2, times the denominator, and then add the numerator. So I get m plus 2 times 2 is 4, plus 1 is 5, halves. 2 1/2 is equal to 5 halves. Now I'm going to subtract 5 halves from both sides. So I get 7/10 minus 5 halves is equal to m. Now we just need to make sure we have common denominators here. Common denominator is 10, so I'm going to multiply this fraction by 5 over 5. That's going to give me a denominator of 10. So I get 7/10 minus 25/10 is equal to m. And then I just subtract my numerators. So that's going to give me negative 18/10 is equal to m. And I could simplify negative 18/10 to negative 9/5. And that would be my answer right here. So the last 5 problems, you will have to convert some fractions to ones that have common denominators before you add or subtract them. Okay, that's going to wrap it up for this video with two-step equations. I encourage you to work through the rest of this packet, and again, write down any questions you may have so we can discuss them at a later time. As always, enjoy the rest of the day, and I look forward to seeing you next time.